Welcome to your daily dose of enlightenment. You've landed on Knowledge Planet where curiosity thrives and the enigmatic is revealed. Daily we delve into a variety of topics, shedding light on the hidden and sharing insights to amaze you. Consider us more than just a channel. We're a growing community, a family of knowledge seekers. We're on a mission to reach global corners, inviting you to join our exploratory. We need you, our growing family. In red, subscribe, become part of our community, share your thoughts, interact with us. A like or even dislike all count. Don't forget to stay updated, ring our notification bell. Stay tuned, stay curious, and together we'll continue to explore the vast expanse of Knowledge Planet. And if I told you that your cell phone battery could last up to 50 years, yes, because in China, a nuclear battery has been developed that can last up to 50 years and could allow you to never charge your phone again. The same goes for drones. You could launch them and never have to bring them down because they discharge every 20 minutes. This is incredible, but what are nuclear batteries? Are they like mini atomic bombs inside the drone that provide energy? Or are they like miniature nuclear power plants? No, folks, nuclear batteries do not harness nuclear fusion or fission reactions. They solely utilize the energy from what's called radioactive decay. But are they safe for our health? No, they are not dangerous, and let's find out why. Today, let's uncover how these batteries work, the difference in the physical principle compared to nuclear power plants, and what potential future scenarios might look like. The battery developed by Beijing. Betavolt, new energy technology, or simply Betavolt, is known as a nuclear battery. Let's clarify something straight away. These batteries do not harness the energy of atomic bombs or nuclear power plants. Nuclear batteries do not involve nuclear reactions of uranium bombardment to split the nucleus, leading to a massive energy release and radioactive waste as seen in nuclear power plants and atomic bombs. Instead, they utilize a completely different physical principle, which is radioactive decay. Therefore, calling them nuclear batteries could be somewhat misleading. It would be more accurate to call them atomic energy batteries, or even better, radioisotope batteries. Now, the prototype battery developed by Betavolt is not much larger than a penny. It's a small, parallel, e-piped with dimensions of 15 mm by 15 mm and a height of 5 mm. Inside, it contains various materials, specifically consisting of a layer of nickel-63 in contact with two plates of a particular type of diamond, like a sandwich. But what exactly is nickel-63? And how does it work? Let's dive into the physics behind it. Nickel is a metal, and like all atoms, the nucleus of nickel contains both protons and neutrons. Nickel-63, however, is a special type of nickel atom with a greater number of neutrons in the nucleus compared to naturally occurring atoms. It is produced in the laboratory by adding a neutron to nickel-62, resulting in nickel-63, which is called a radioisotope. Now, this is where it gets interesting. As we delve deeper into the realm of nuclear batteries, it's essential to understand the key player in this innovative technology, nickel-63. When we talk about nuclear batteries, or more accurately, radioisotope batteries, we're essentially discussing the energy generated by the decay of nickel-63. This unique isotope is inherently unstable due to an extra neutron in its nucleus, which it is constantly trying to shed. In its quest for stability, nickel-63 undergoes radioactive decay, a process that results in the transformation of a neutron into a proton. This shift further leads to the emission of an electron, which is precisely what we need to generate electricity. In the radioisotope battery developed by Betavolt, the nickel-63 is sandwiched between two plates of a specific type of diamond. The energy from the electrons released by the decay of nickel-63 is converted into electrical energy by these diamond plates. The physical process that enables this diamond to generate electrical energy is quite complex and involves the principles of band theory and other factors. However, the critical point to note here is that the principle of radioactive decay, which powers these batteries, is fundamentally different from the nuclear reactions in nuclear power plants and atomic bombs. While the latter involves uranium bombardment to split the nucleus, leading to a massive energy release and radioactive waste. The former relies solely on the natural decay process of nickel-63. So the next time you hear about nuclear batteries, remember, it's not about mini atomic bombs or tiny nuclear reactors. It's all about harnessing the power of radioactive decay to keep your devices powered for an incredibly long time. Stay tuned as we explore other fascinating scientific discoveries in our upcoming videos. Now here's an interesting fact. Harnessing radioactive decay to produce energy is not a new concept. In fact, it has been used for decades in space missions. Those impressive rovers NASA sends to Mars, they're powered by this very technology. The Mars rovers, including the latest Perseverance, use a multi-mission radioisotope thermoelectric generator, MRTG, to convert the heat from the decay of plutonium-238 into electricity. So, with such a powerful technology at our disposal, you may wonder why we don't have nuclear batteries in our everyday devices. Well, the answer lies in the very element used. Plutonium, unlike nickel, is not only much rarer and costlier, but it's also far more challenging to handle and miniaturize. The safety measures required for handling plutonium are extensive, making it impractical for widespread commercial use. Moreover, miniaturizing this technology while maintaining efficiency poses a significant challenge. The MMRTGs used in space missions are bulky and wouldn't fit in your everyday devices. This is where nickel-63 comes into play. It's safer, cheaper, and more feasible for miniaturization than plutonium. However, while the technology is promising, there's still a long way to go before we see nuclear batteries in our smartphones and laptops. But one thing is for sure, the future of energy production is bound to be exciting. Stay tuned as we continue to explore the fascinating world of scientific advancements. Now let's address the elephant in the room, the safety of these nuclear batteries. After all, when we hear the term nuclear, it's only natural to have concerns about radiation. But rest assured, the decay of nickel-63 does not produce ionizing radiation, the type that's harmful to our bodies. Unlike the gamma rays emitted in atomic bombs or nuclear power plant waste, nickel-63 emits only electrons. These can be easily shielded even by a thin layer of aluminum. It's also worth noting that the company behind these batteries claims they are absolutely safe, emit no radiation, and are suitable for use in a variety of applications. This includes medical devices such as pacemakers and artificial hearts, where the use of a stable, long-lasting power source is crucial. So, not only are these batteries potentially revolutionizing our everyday devices, but they could also significantly improve the quality of life for individuals relying on such medical aids. But remember, while the prospects are promising, the technology is still in its early stages and requires further development and testing. Stay tuned as we delve deeper into the future potentials of nuclear batteries in our next segment. In our journey of exploring nuclear batteries, it's essential to grasp the risks involved. From the decay of nickel-63, a stable isotope of copper-63 is produced, resulting in no radioactive waste products. This is a significant advantage over other forms of nuclear power, which can produce hazardous waste that lasts for thousands of years. However, it's important to remember that these batteries should not be tampered with. Just as opening a lithium-ion battery can be dangerous, so too can exposing yourself to a nuclear battery if it's not stored correctly. In essence, while they are not a health risk when used properly, mishandling can still pose hazards. It's also important to note that the field of nuclear batteries is still young and there's much to learn. While the technology is promising, it's still in the early stages of development and testing. As we move forward, we can expect to see more research and perhaps even practical applications of this technology. But for now, it's an exciting glimpse into the potential future of power generation. Stay tuned as we wrap up our exploration of nuclear batteries in the next segment. As we dive deeper into the fascinating world of nuclear batteries, let's take a moment to imagine the potential impact of this technology on our everyday lives. Consider Betavoult's new battery device, which is said to hold a charge for an astounding 50 years. This could mean never having to charge your smartphone again, effectively revolutionizing the way we use our devices. No more scrambling for a charger or worrying about your phone dying in the middle of an important call. Your device would simply be ready to go, powered by a battery that could outlast the device itself. Moreover, the versatility of these nuclear batteries is not just limited to their long lifespan. They can also operate within a wide temperature range, from -60 to 120 degrees Celsius. This eliminates the common temperature-related problems we often face with traditional batteries. Imagine no more overheating phones on hot summer days or battery drain in freezing temperatures. The potential implications of this technology are vast, from personal electronics to electric vehicles and even space exploration. But as always, with great power comes great responsibility. We must ensure that as we advance this technology, we do so with the utmost attention to safety and sustainability. As we step into this exciting future, let's remember to tread carefully, ensuring that the potential benefits outweigh any potential risks. In the present state of affairs, the Chinese company Betavoult has only managed to produce a small prototype of their nuclear battery. Despite its small size, this prototype is a significant stepping stone, paving the way for this groundbreaking technology. It may not generate a substantial amount of energy yet, but the goal is to reach higher power levels by 2025. This ambitious timeline is a testament to the relentless efforts being put into the development and refinement of nuclear battery technology. Once these power levels are achieved, the next step is mass production. If successful, this would mark a monumental milestone in the history of power generation, the birth of the world's first mass-produced nuclear battery. The journey towards this goal is fraught with challenges, but the potential rewards are astronomical. A future where our devices are powered by long-lasting, efficient nuclear batteries could be just around the corner. But as we head towards this exciting prospect, we must remain cognizant of the potential risks. The road to mass production must be tread with caution, ensuring that safety and sustainability remain at the forefront of all development efforts. The world watches with bated breath as we stand on the precipice of a new era in power generation. The future is bright and it's powered by nuclear batteries. As we envision the potential future, it's evident that if Betavoult manages to commercialize these batteries, it could truly be a game changer. Imagine a world where our smartphones boast virtually infinite battery life. Visualize drones that can operate the whole day without needing a recharge. The possibilities are endless and could revolutionize the way we interact with technology. However, turning this vision into reality is no easy task. Producing ultra-thin layers of nickel-63 is a complex process. Obtaining the special type of diamonds required for this technology presents another challenge. And the cost of production? It's nothing to sneeze at. It's clear that the road to mass production is not without its hurdles, but with every challenge comes an opportunity to innovate and push the boundaries of what's possible. As we stand on the brink of a new era, the question remains: are we ready to embrace the future of power generation? Only time will tell. As we stand on the brink of a new age in power generation, it's crucial not to overlook the potential environmental and safety implications of these novel nuclear batteries. Rigorous testing will be necessary to ensure that they are not only efficient but also safe for use in everyday devices. We need to assess whether they pose any radiation risks to users or the environment. The disposal of these batteries will also need careful consideration. Will they contribute to the growing problem of electronic waste? Or can they be recycled in a way that's both safe and environmentally friendly? These are questions we need answers to before nuclear batteries can genuinely be considered a viable alternative to traditional batteries. Rest assured, we'll be keeping a close eye on Betavoult's progress and will bring you any updates in a future video. As always, the march of technology is fascinating, but it also comes with responsibilities that we must not ignore. As we wrap up this enlightening journey into the world of nuclear batteries, let's reflect on all we've learned. From their operation using nickel-63 to their potential applications in space missions, these innovative power sources hold immense promise. However, as we've seen, they also pose significant challenges in terms of safety, environmental impact, and mass production. But remember, every great invention in human history has faced its share of hurdles. It's through addressing these challenges that we refine our technologies and make them safer, more efficient, and more accessible. The story of nuclear batteries is still being written, and we're excited to see where the next chapter takes us. Thank you so much for following along. I hope you enjoyed this in-depth look into nuclear batteries, or rather, radioisotope batteries. And I hope it's clear that they have nothing to do with atomic bombs or nuclear power plants. Thanks again for being here with us, and as always, we'll see you here on Knowledge Planet, the power of knowledge. Until next time, in this whirlwind of a world, staying connected has never been more important. Here at Knowledge Planet, you have found a place of engaging content, a vibrant community, and shared experiences. When you hit that subscribe button, you're not just joining a channel, you're becoming part of a family that grows with every click, every share, every comment. So, don't be a stranger. Dive into the conversation, add your voice to the mix. Agree, disagree, all perspectives are welcome here. And remember, sharing is caring. Pass along our videos to friends who could use a light bulb moment, a moment of insight, or just a break from the everyday. We strive to provide you with content that enlightens, engages, and fuels your curiosity. Your participation helps us make knowledge accessible to all. So, let's keep the conversation going, let's keep learning, and let's continue our journey into the cosmos of knowledge together. Join the Knowledge Planet family, because together we can make the power of knowledge reach every corner of the world. And here's a little secret we've been keeping for last. You see that little bell icon? That's your VIP pass to all things Knowledge Planet. Click it, and you'll be the first to know when we have fresh content ready for you. It's like your own personal notification system, ensuring you never miss a beat. So what are you waiting for? Subscribe, comment, share, like, or even dislike. We welcome it all. And don't forget to ring that bell. It's our way of growing this family one video at a time. So until next time, keep your curiosity alive, and remember, knowledge is the greatest adventure of all. Goodbye, and see you on the next journey into the cosmos of knowledge.